Hello students, this is the video demonstration of series of experiments starting with optical fibers of second batch. So as you might be knowing, this is optical fibers, and what is the aim of this experiment? The aim of this experiment is to find out the numerical aperture and the angle of acceptance of optical fibers. What is numerical aperture? It is the light gathering capacity. First, let's understand the theoretical basis on which this experiment is designed. Let's take for illustration a water source here, and this is where you have to lead the water, and a wall is in between. How do you take the water from here to here? The obvious answer would be take a pipe and take it around the wall, or take it across the wall, jump the wall and go to the destination. So what you have effectively done is you have directed the water through the pipe in a path which is not natural for water. Now the question is, if the same thing can be done with light, then the answer is yes. But instead of this pipe, you have to use optical fiber. So how these optical fibers are constructed? Let's briefly look at the physics of optical fibers. You know refraction. What is refraction? Refraction is a process in which a ray of light bends while going from one medium to another medium. If this is the rarer medium and if this is the denser medium, it bends towards the normal. So this is the normal line. So this is angle of incidence, angle of refraction. It bends towards the angle of towards the normal. If you flip the media, then if this is denser and this is rarer, then it bends away from the normal. So this is the physical principle which we exploit to create optical fiber. There is, when you further this process, you will end up with a phenomenon which is called total internal reflection. So what is that? Suppose that you take a ray, it passes from denser medium to rarer medium. When you shine it on the interface, what will happen? It will deviate away from the normal. So this is ray 1, this is the refracted ray. Okay, if you deepen the angle, if the angle is more, it will diverge away from the normal more. There is one particular angle at which if you just refract, it just passes through the interface. If you make the angle more than that, then it will come back to the same medium. It is deviating away from the normal more and more depending upon the increasing of the angle of reflection. So after a particular angle called critical angle is reached, it will come back to the same medium. This is the property of light which we have to exploit in making this optical fiber. This is the optical fiber, and you have a denser medium here which is called the core, and you have a rarer medium called cladding. If you pass this ray and make this angle of incidence, more than the critical angle, then it will come back to the same medium. So if you have a series of such total internal reflections, then the light will get trapped inside, and this is what produces an optical fiber. Okay, so in this way, if you have this optical fiber, just as the pipe can direct the water in any way you want, you can direct this in any way you want. This is what is known. This is the working principle of optical fiber. Now in this experiment, what we have to do is we have to find out the numerical aperture of the optical fiber. How do we find out? So suppose that this is the edge of the optical fiber from which the light streams out. Since it just, if you shine a torch, what will happen? In a conical fashion, it will spread out. It will also spread out in a conical fashion. If I intercept this with a screen, it should give you a circle. And each circle has a diameter. And if you measure this diameter, okay, and then this line which it makes with the axis of the optical fiber, if you call this as theta A, this length, if you know, and if you know the half of the diameter, you can find out theta A. How? It is, you know, this is the opposite side, this is the adjacent side. So when you know opposite and adjacent side, you can easily take tan theta. Tan theta is, it is opposite divided by adjacent. So this ratio, if you can calculate, tan theta is equal to d divided by 2l. So what is theta A? Theta A is tan inverse of d divided by 2l. That will give you theta A. What is numerical aperture? Numerical aperture is n0 into sin theta A. N naught is the N1 and N2 are the refractive indices of core and cladding. N naught is the refractive indices of the refractive index of the air surrounding medium. You can take it to be equal to 1, approximately equal to 1. So that is, this is equal to 1. So sin theta A is what you have already found out, and if you put it here, that will give you numerical aperture. And how do you find out the angle of acceptance? Angle of acceptance is sine inverse of this. This is the whole procedure. This is the theoretical foundation on which this experiment is made up of. Now we will come to the experimental part. How do we come to, what is the experiment we have to do? This is the setup. We need to have a laser. This is a solid state laser, and as you know, this laser light always has a straight line. It passes in a straight line, as you can see. Can you see this? It is going in a straight line. You have to make it to go in any way you want. I will circuit this, and this is a loop which I have created, and what I want is, I want to direct light in this circuitous path. You can easily see that this is not something which is natural for a light. Even though I have made a loop here, it will follow this loop and it will come out. This is the end edge after which this will stream out. Now, this is to do this experiment, what I have done is, this is a set of concentric circles of whose diameter I already know of. Okay, this is the first circle. The diameter is 0.5 cm. This is 1 centimeter, 1.5, 2, 2.5, 3. These are concentric circles of which diameter I know. So if the diameter I know, d by 2 is also I know. So what I must do is, there is a length scale which is attached to this. Right? There is a length scale which is attached to this. I need two parameters. One is this L, the distance between the edge of this, and wherever I am intercepting the cone. And the second thing is, you need this d by 2. D already I know from this, that's why d by 2 I can know. So the only experimental part which you must do is, you must take this like this, and you should go to a distance in which the whatever light comes out of that will completely fill the first circle. See, it is now clear that it is somewhere filling the first circle. So when it is filling the first circle, what does it mean? It means that at this distance of L, the first circle is completely filled. I know the distance at which it fills the first circle. I can read it from this scale, and that I can write it here. So this is how the readings are to be taken. So first circle, I know the diameter to be equal to 0.5. So in this scale, in the length scale of this, when I place it at 0.6, this will completely fill this, as I told that this will completely fix at 0.6. Now I will do it for different circles. Second is 0.1 centimeter, 1.5 centimeters, 2 centimeter, all these things are marked here. At what distance the laser completely covers the circle, completely covers the area in that circle, is what I will take down. Now what is theta A? As I told you, it is d by 2l. This is d, diameter of the spot, and this is the length between the edge of the optical fiber to the screen. So that I have. So theta A is tan inverse d divided by 2l. So that I will calculate. That will give me theta A. Numerical aperture is n naught into sin theta A. N naught is 1 because the surrounding medium is here. Theta A is the input from this column. So I will compute this. So when I take the average, I am going to get the average numerical aperture. That is the numerical aperture which I am going to get. So numerical aperture is this one. Okay, numerical aperture is the average of all these readings. And one more thing, I have to get the angle of acceptance. Angle of acceptance is nothing but, it is either you can take the sine inverse of numerical aperture. Sine inverse of numerical aperture will give you this theta. Okay, this is itself is the experiment. These two things you have to find out. Thank you.